Today we're going to talk about factoring specials. And there's several different special types of polynomials that have special forms, and that's why they call them specials. And what this means is there's actually formulas that you can use, and this is kind of a shortcut method. Now, for everything but the last two, you can still use your normal methods. It's just you'll always get this same kind of format whenever you do this. So if you can learn to recognize the specials and have the formulas or the patterns for the formulas memorized, it'll make a lot of sense and it'll save you a lot of time. So the first one is difference between two squares. And with this, what it's going to look like is something squared minus something else squared. And if you remember when we multiplied conjugates, what we got was that middle term disappearing. And so now we're seeing something without a middle term, and we need to get back to the conjugates. So, if you recognize that difference between two squares is just going to be the product of two conjugates, you can realize that the first term of each conjugate will be the square root of the first term of your polynomial, and the second term of each conjugate will be the square root of the second term of your polynomial. So sometimes students have trouble distinguishing between something that's difference between two squares and something that's not. So what it might look like is like x squared minus 25, where the thing that's squared here is x, and the thing that's squared here is 5. Okay. Another thing that might be a difference of two squares is 4x squared minus 9y squared. The thing that's squared in the first term is 2x, and the thing that's squared in the second term is 3y. So these can have a lot of different looks to them, so don't be afraid to see, you might even see something like x to the fourth minus y squared. The thing that's squared here is x squared. The thing that's squared here is y. Okay, so again, a lot of different looks to these, so just look for basically even exponents. Now, the other thing you're looking for is the minus sign between them. If you don't have that minus sign, say you have x squared plus 25, that is not difference between two squares. Okay, that's actually prime. It's not factorable. Okay, so if there's a plus sign, it is not factorable. So let's practice using this formula for a little bit. Remember, we are just looking for conjugates, and they relate to the square root of the first term, which is x, and the square root of the second term, which is 7. So it's just going to be the conjugates x plus 7 times x minus 7 that this factors into. Let's look at the second problem here. What's squared with this first term? Well, that's x. What's squared with the second term? That's 11. So x plus 11 times x minus 11. Pretty easy. Here we have x squared minus y squared. Well, the square root of x squared is x, the square root of y squared is y. So we're going to have x plus y times x minus y. And again, this is probably the most simple of all of them. Let's go on to what's called a perfect square trinomial. And this is what happens when you square, like x plus 1 squared, ends up being this trinomial. So we have x plus 1 times x plus 1, and we end up with a double term in the middle. Okay, so what this looks like with our formula is, let's see, so something like a plus b squared is going to equal a squared plus 2ab plus b squared. It also could be a minus b squared, which is going to equal a squared minus 2ab plus b squared. Okay, So when we have a minus sign in the binomial that's squared, we're going to have a minus sign for our middle term as well. But that last term is always positive. Okay? So when we're looking to factor this, we have to identify what's squared in the first term. Well, that's x. What's squared in the last term? That's 1. And is the middle term 2 times each of these? Well, 2 times 1 times x is 2x. So we know that that can be factored into, my eraser here. It can be factored into x plus 1 squared. Same thing with the next one. The thing that's squared here is x. The thing that's squared here is 3. And 2 times 3x is 6x. So this factors to x plus 3 squared. Same with the last one. What's squared here is x. What's squared here is 2. And 2 times 2x is 4x. So we're going to have x minus 2 squared here because of this minus sign. So remember to look for first and last terms that are squared. Check the middle term to see if it is twice or 2 times what is squared in the first term times what is squared in the last term. Okay? Now the last thing is sum or difference of cubes. And this is always kind of a tricky one because the formula is so lengthy. But here we're needing to identify what's cubed. Well, in the first one it's x. And in our second term it's 1, because 1 times 1 times 1 is 1. So we have 2 terms in the first one and 2 in the second. And we just have the things that are cubed with their original sign in our first factor. Then we square the front, square the back, and multiply them in the middle with the opposite sign. Okay? Hope that helps. Let's try another one. The thing that's cubed here is x. The thing that's cubed here is 3. Remember, our first term is going to keep the original sign, so x minus 3. Square the front, we get x squared. Square the back, we get 9. Multiply the 2 in the middle, and flip the sign, and so we get plus 3x plus 9 for the remaining portion of this. So we'll get some more practice on these in class, and I hope that helps. Watch it several times if you have any questions, especially on this last sum or difference of cubes, because it's not like difference between squares where you can only have a minus sign in the middle. With this one, you can have a plus sign as well.